Now we'll look at how to set bit values in our final tutorial on working with bitwise operators. We want to go ahead now and set bit position B0 to the 0 state. So here's our layout with all the bit positions. Once again, we're working with an 8-bit number, but this will work for any size number. Right? 8-bit is our simplest example. And so here we have bit position B0. We don't know what's there now. And so you can see that I've labeled all of these as X. We don't know what's there. But we do know when we get done, we want B0 to actually be a 0. We want to maintain all the other values of X, right? We don't want to change any of the values stored in B7 through B1. We simply want B0 to be a 0 when we get done. So we're going to use a bit mask. We're going to use AND, right? We have the Boolean algebra axioms that X ANDed with 1 will produce X, and then X ANDed with 0 produces 0. So if we create a bit mask that we AND with what's stored in the value, so if we take whatever's stored here, this value of X, and AND it with 0, we know that will produce a 0. For every one of these other bit positions, we know that if we AND these with 1s, we'll get the same value that's in there back. So we create a bit mask then, where we place 1s in every position that we want to preserve, and then a 0 in the one that we want to clear, or we say we'll set that to 0. And the two together, and when we're done, B0 will actually be a 0. Similarly, if we wanted to set bit position B5 to the 0 state, this position here, that means we want to maintain what's stored in every other position. So B7, B6, B4 through B0, our bit mask values are all 1s. Our 0 goes here in B5. When we take what's in value and it with bit mask, then we'll preserve all of those other values. B5 will be set to 0, and we'll have accomplished our task. Right. We can also set multiple bits. In every example we've had so far, we've read 1 bit at a time. Right here, we're going to set multiple bits. So we can set multiple, and we can read multiple. To set multiple, we want B6, B5, and B2 to be 0. So B6, B5, and B2, our bit mask values are all 0s. In every other position, B7, B4, B3, B1, and B0, we put 1s in our bit mask. We AND that then with value, and we get 0s in B6 and B5, B2, and we preserve the value that's stored in that number in every other bit position. Like, right. So our bit mask, right, you can see is 110011, 1011, or hex 9b. Right, let's take a look at, so that's to set everything to the 0 state. Sometimes we want to set things to the 1 state. So we want to set a number to 1s, we're going to use the OR gate. Right, we know that XORed with 1 produces a 1, and XORed with 0 will give us X. So once again, since we want to set B0 to the 1 state, when we get done, we'll see that we want B0 to be a 1 here. We're going to place a 1 in the bit mask. We want to preserve the other values in every other bit position, so we place 0s there. We then OR this bit mask, which is hex 01 for the bit mask. We OR that with value to produce then B0 will be a 1, every other position will be set. Right, so the difference is, when we want to then set something to 0, we use the AND operator. We use a bit mask of all 1s for the numbers we want to preserve. We put 0s for the ones we want to set to 0. When we want to set a bit position to a 1, our bit mask will contain a 1 in the positions that we want to change, 0s everywhere else, and we use the OR gate. Similarly, here's an example where we could set 2 bit positions to 1, so B7 and B2. So we're going to put a 1 in the bit mask in B7, a 1 in the bit mask in B2, 0s everywhere else. So our bit mask here is, this is 8, this is 4, hex 8, 4. And when we OR that with value, we'll get our results that we want. B7 will be a 1, B2 will be a 1, every other position will be preserved. Right. And we've got 2 examples then. We've got example 13 that's going to set B4 and B3 to 0s, and then we'll set B4 and B3 to 1. So let's just pop up code blocks here. All right, so here's example 13 that you've been given. We're going to set B4 and B3 to 1s. That means that we're going to put B4 and B3 to zeros. We want to put a 0 in the bit mask position at B4 and B3. Everywhere else we have ones. So our bit mask then in this case, this is E, hex E, and hex 7. Our bit mask is hex E7, right? So I'm using then FF here as the value. We know that FF is all ones. So when we get done, I'd like to be able to see that we have zeros in these two positions and ones everywhere else. So you can see here, we're just going to print out this information. The before, we're going to AND value with bit mask, and we're going to store it back in value. So let's just run the cursor here. So we can see value, well, hex FF is 255. Bit mask for E7 happens to be a decimal, 231. When we perform this operation now, so next line, now we can see that value is the same as bit mask. In this case, that worked out simply because all of our bits were ones. But that means then that this bit position and this bit position were both changed to zeros. And if we go ahead and print those out, pop up that window, we can see the before, we had the hex FF, after we have the E7. All right, so there's a coding example, right, to help you see then how to set up your bit mask, right, how to write it out in hex. What I suggest you do in your programs is to go ahead and write out your bit mask here in comments, so you'll remember which bits you're trying to affect. It'll be easier to check in your coding. All right. And then let's take a look at example 14. So in 14, we're going to set the same bits, B4 and B3, we're going to set them to ones. So what I did was I started out and made value equal to all zeros. So when we get done, we'll easily be able to see the bit positions where we have ones. Our bit mask here now, remember when we want to set something to a 1, we're going to use that OR operation. So both bit positions B4 and B3 in our mask will be ones. Every other bit position will be a 0. So this is a hex 1, and this is a hex 8. So our bit mask is hex 18. And when we build and run this, sorry, that's the old one. I just hit run, build and run here. All right. Let me clean out my workspace. For some reason, it did not rebuild. Code blocks is slowly chugging along this morning. Okay, so before our OR operation, our value was 0. After the OR operation, our value is hex 18. That means bit B4 and B3 are both set. And so we achieve that once again. Remember, when you want to set bits to 1, you're going to use the OR relationship. You're going to put ones in the bit mask that you want to set, zeros everywhere else to maintain that. So those Boolean axioms are important to remember. If you remember those axioms and how these gates work, then you can always go back and derive this result. Okay. So now we know how to set things to zeros, how to set things to ones. Let's look at how to toggle a bit. We're going to use the XOR gate to toggle a bit. Toggling a bit means we're going to invert that particular bit. Right? If that bit is a 0, it becomes a 1. If it's a 1, it becomes a 0. So using the Boolean axioms for the XOR relationship, we know that X XORed with 1 gives us not X. X XORed with 0 gives us X. So in our bit mask, when we're going to set the bits we want to toggle to ones, and the other bits to zeros. And then we're going to take our value and XOR it with that bit mask in order to toggle those individual bits. So in this case, if I want to toggle bits B4 and B3, right, I use the idea that XOR, if I'm going to XOR something with a 1, I'll invert that. So B3, excuse me, wrong button. I'm going to set bits B4 and B3 to ones in my bit mask. Everywhere else, every other position in the bit mask, I'll set to a 0. So this bit mask then is a hex 18. Now, when I XOR value with bit mask, whatever was stored in the value, whatever this is, whether it's a 0 or 1, my output here is not X and not X. Everywhere else, I maintain X. So there's an example then of how to toggle that. All right. Now here's some practice for you. So at the ends of these slides, based on the concepts that we've learned in these lectures, here are some things you can practice. Right? Typically in our class, these are things that end up on quizzes and tests. So I would know how to do all of these. You'll guaranteed to see exercises or problems like this on an exam. Right? So you want to practice converting 8-bit binary numbers to hexadecimal. Here's some 16-bit binary numbers to hexadecimal. And then you're going to convert hexadecimal values to binary. So this would give you 16 bits with 4 hex. Here, with 2 hex numbers, you'll have 8 bits in the result. Here's some other conversions practice then. Given the following declarations and initializations, we want to know what is stored in Z after these operations are performed. So after X is ANDed with Y, what will be the hexadecimal value of X ANDed with Y? Right, that we store in Z. So here in all of these, what will be the value stored in Z? Write that out in hex form. Like I said, you'll see problems like this on a quiz or an exam, and it's good to know how to do this as well for your programming. Finally, the final practice problem is, suppose we have the following definition. So now here you're going to work with a 16-bit number, an unsigned 16-bit named sval, and you're going to want to write code. So try to write some code. You're going to create the bit mask. What code would it take to set bit 13? So set bit 13 to 1. Clear bit 4 means set it to 0. Right, clear it to 0, and then toggle 15 and 14. Right, that's the end of our tutorial. Start practicing your bitwise operators. They're used a lot in embedded programming.